Hey everybody, this is chapter 10, section 1. We're looking at areas of parallelograms and triangles. So remember, a parallelogram is a many-sided figure. It can be a parallelogram, it could be a rectangle, it could be a rhombus, could be a square. So we need to make sure that we know that the formula we're going to use is going to be for all these different things. Okay, so in the box they give you a rectangle, and they also then give you a parallelogram, and for both I need a base and a height. Heights need to be vertical. So if you look at the rectangle one, the sides are going to be vertical because the angles are at 90, but a parallelogram does not have that. So somehow we need to show you a vertical height, and that's going to be with that right angle and the H with the dotted line in the box. Okay, so we're going to go ahead and do these couple here. In this first one, for example, my height is going to be 4 and my base is going to be 5. 4 is the vertical height. So I'm going to go ahead and get the area equals the base times the height, which is 4. And that's going to give me 20. We're also important to use your units. So this was in inches, and we indicate the areas by squared that way, or we could write it out as 20 square inches. Okay. On this one, a little bit different. The base is what it sits on. So the base is going to be 2, and the vertical height is going to be this 3.5. So we're going to go ahead and take 2 times 3.5, and when I multiply that out, I'm going to get 7 centimeters squared, or 7 square centimeters. Okay, I'm not worried about which way you label it, but proper way is to make sure you put the units on there too. Okay. The next question, a little bit tougher. They want me to find DE in this one, but I need 2 different calculations to do that, and then use that to kind of prove area. So I'm going to take this 9, is really going to be the height of it, and the base in this case is going to be this 13. So I'm going to take 13 times 9, multiply that up. I'm going to get 117, and we were going inches squared on that. So now what I'm going to do is I'm going to take that 117 is the area. I'm going to now take this base 9.4 and multiply it to the vertical height, which is the dotted line. That's DE. So you call it H, you call it DE. They want a DE, so I'm going to use that. And so I set the equation up. I can go ahead and divide both sides by 9.4, and that's going to get me DE. And when I get this, it comes out to about 12 point whatever. So I had to round it to 12.4. And then what I did, just to check it, I took the 9.4 that I started with and the 12.4 I just got, and it came out to about 116.56, I believe. And so, because of rounding, that's going to be close for us. Okay. So that's your 2 different calculations, getting area, and that's finding DE. Okay. And when we're looking at this one, they're asking how are the formulas for a parallelogram and a triangle similar and different. Well, for a parallelogram, we did this last semester. I could go ahead and cut that. Well, now I got 2 triangles, and I still need to get a vertical height to find the area of a triangle and also to find the area of a parallelogram. So for the similarities, I need a base and a height to calculate areas. For a triangle, though, then I have a little bit different. If you look at this, I cut the parallelogram in half, so really 2 triangles make up a parallelogram. So then that brings us down to the area for a triangle. It's still a base times a height, but I'm going to have to go multiply it by 1/2. Some kids don't like that. I don't like it either. I changed this formula into the base times the height and divide it by 2. So you're doing the same thing. That's just a little bit more user friendly on that. So You know, I'm not going to tell you which one to use, but I like using the one I wrote up there for you. Okay. You got this little figure here with a triangle and a sitting on top of a square, and they want me to find the area of the following figure. Well, there's no formula to get that figure, but I can get the area of my triangle is going to be the base times the height divided by 2. And so for this case, if I'm assuming it's a sitting on a square because they got all these congruencies. So this base is going to be 6. So I can go 6 times 8 divided by 2, and that's going to get me 48 over 2, and that will allow me to reduce it down to 24, and that would be inches squared. And then for the square, I'm going to go ahead, I'm assuming it is a square because it's all congruent, so all the sides are 6. So 6 times 6 is going to get me 36, and that's going to be inches squared. Okay, so now what I can do to get this figure, the triangle on top of a square, I could take the areas of both, so 24, add it to 36, and that's going to get me 60 inches squared. Okay, so you're going to get a bunch of those. Sometimes we have formulas for these different figures, like the trapezoid, stuff like that, but that one, you know, I got to find the area of each figure, add it together to get the whole thing. All right, we're going here to this particular graph. If you guys remember in transformations, we're going to take these different equations and graph it. Remember in transformations, when we had translation lines or lines of symmetry, y equals x is this particular line. That's the equation of that line. X equals 0. Remember, that was kind of a funny way of saying the y-axis, if you remember that. And then this is over here. Sorry, I can't move the recording button, but it says y equals 6. So remember, y equals 6 is going to be this horizontal line through here. And if you'll notice now, I've got this triangle up here, and I'm assuming it's going to be right, since those are a vertical and horizontal line that are intersecting. They want me to get the area now of that figure. So counting squares, you know, I'll call this my height. I'll call this one my base. Doesn't really matter. And I'm going to multiply those together, divide it by 2. I get 36 over 2, which gets me 18. They did not give me any units, so we'll just stick with 18. Okay, so that was kind of how to find the area of a parallelogram and a triangle. I think most of you guys are pretty good at that. So I want you to do the assignment for this particular one. It should be on your parent score that you got earlier. Should be pretty easy. You've probably done this before in other classes. Okay, all right, good luck.